When a half cell is constructed from a redox couple, there is an electrical potential established between the redox electrons on red and the positive charge of the unfilled orbital on ox. This electrical potential is called the half cell potential of the couple. If the nuclear charge experienced by the electrons in the redox orbital is high, the resulting electrical potential is high. Therefore, couples with low-energy redox electrons have high half-cell potentials, and those with high-energy redox electrons have low half-cell potentials. The cell potential of an electrochemical cell is simply the difference between the half-cell potentials of the two couples. That is, E cell equals E high minus E low. Couple number 1 is connected to the high terminal in the diagram, so E high equals E1. Similarly, couple number 2 is attached to the low terminal, so E low equals E2. A cell is spontaneous if the cell potential is positive, so E high is greater than E low for spontaneous cells. That is, electrons transfer from couples with low half-cell potentials to couples with high half-cell potentials. For example, when a standard copper 2 plus copper half cell is attached to the high terminal and a standard iron 2 plus iron half cell is attached to the low terminal, the cell potential is given as the difference between the two half-cell potentials as shown. The fact that the cell potential is 0.78 volts means that the electrical potential experienced by the redox electrons is 0.78 volts higher on copper than on iron. Since the electrons experience a more positive potential on the copper, their free energy is lower. So we know that the redox orbitals on copper are lower than on iron and that the electrons flow spontaneously from iron to copper. Consequently, the spontaneity of a redox process could be determined from the half-cell potentials of the two couples, and the extent of electron transfer could be determined from the standard half-cell potentials. However, absolute potentials cannot be measured, so half-cell potentials are determined relative to a standard reference half cell, which is established as the standard hydrogen electrode, or She. The She is assigned a half-cell potential of 0 volts, and by convention, it is always attached to the low or negative terminal. Thus, the relative standard half-cell potential of a copper 2 plus copper couple is determined by attaching the standard copper half cell to the high terminal and the She to the low terminal. The resulting cell potential is E copper minus E of the She, which is 0.34 volts. The standard half-cell potential of She is 0, so E cell equals E copper equals 0.34 volts. Recall that the positive terminal of a galvanic cell is the cathode, or the cell where reduction occurs. Thus, E copper equals plus 0.34 volts is called the standard reduction potential of the copper 2 plus copper couple, because the couple is attached to the high terminal. The copper 2 plus copper couple is 0.34 volts higher than the She, so electrons on copper have a lower free energy than they do on hydrogen. Consistent with our previous discussions, we place the couples in terms of their relative energies, with couples at high energy and low potential at the top. The copper 2 plus copper couple is at higher potential or lower energy, so electrons flow spontaneously from hydrogen to the low energy orbital on copper 2 plus to produce 2 protons plus copper metal. When a standard iron 2 plus iron couple is attached to the high terminal, the cell potential is minus 0.44 volts, so the half-cell potential of the iron 2 plus iron couple is 0.44 volts lower than that of the She. The lower potential puts the energy of the redox orbital on iron above that of the proton. Consequently, electrons flow from the high energy orbital on iron into the lower energy orbitals on the proton to produce iron 2 plus and H2 gas. Comparing the copper 2 plus copper and iron 2 plus iron couples, we would predict that the spontaneous direction of electron transfer is from the high energy orbital on iron to the lower energy orbital on copper 2 plus to produce iron 2 plus and copper, and that the standard cell potential would be 0.78 volts, which is the measured value.